Okay, so we didn't really spend a whole lot of time doing examples in class, so I wanted to work another couple examples for you guys. That way you could watch a video tonight, because this stuff is kind of hard to keep in your mind. So the first one, we have 2x plus 3y to the fifth, and we want to expand that. Okay, then the second one is m minus 5 to the eighth. And we don't want to expand that one, we just want the seventh term. So remember in class we wrote out Pascal's triangle. Okay, that was 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 5, oops, 1, 5, 10, 10, 5, 1. Okay, and remember those come from adding those two numbers together, then that gets you to your next term in the triangle. Okay, remember that these next terms in line come from adding the two above them. Okay, so the next ones here, add those, add those, add those, and that gets you to the next term in the triangle. So looking at the triangle, we always start with the 0 power, then we go to the first power. So if we want to expand to the fifth power, that'd be 0, 1, 2, 3, 4, 5 right here. N equals 5. Okay, so 0 power, 1 power, second power, third power, fourth power, fifth power. So these are the ones we want to use. Alright, so those are our coefficients. Now this would be my A right there. That would be my first term. That's my second term I'm using for the binomial expansion if we follow those patterns. So the first one starts out, I have 1, because that's my first coefficient. And then I'm going to have 2x to the fifth, because you always start with that first one to the biggest power, and then the 3y to the 0. Once you have that first term down, the rest should be pretty straightforward, because that number is going to keep going down by 1, that number is going to go up by 1, and that number out front just matches your triangle. So it'll be plus 5 times 2x to the fourth, 3y to the first, plus 10 2x to the third, 3y squared, plus 10 times 2x to the second, 3y cubed. Okay, remember when these are going down, these are going up, but you always want them to add to the degree, which is 5. We always want them to add to 5. So here, 3 and 2 is 5, so I know that here, if that's going down to a 2, that one has to be a 3 in order to keep our degree at 5. So I'm running out of space here, so I'm going to write them down below. So I'm there, so I need a 5 and a 1. So 5, 2x to the first, 3y to the fourth, and then plus 1, 2x to the 0, 3y to the fifth. Okay, now we actually have to multiply it all out. So we're going to use those numbers with their exponents and multiply them all out. Alright, so the first one right here, 2x to the fifth, 3y to the 0, that just turns into a 1. Because anything to the 0 power is a 1. I can take care of that back here too. Anything to the 0 power is a 1. So we're doing 2 to the fifth. That's 2 times 2, which is 4, times 2, which is 8, times 2, which is 16, times 2, which is 32. So our first term is 32x to the fifth. Now the second one, you're going to have 2 to the fourth. Okay, that's 16 times 5. Once you start getting bigger numbers like this, you might need to use your calculator. So it'd be 16 times 5 times 3. We have that 3 there still. Okay, that gives you 240 if you use your calculator. And then we're going to have x to the fourth, y to the first. Now the next one here, we got a 10 times 2 cubed, that's 8. So that's 80 times 9. Okay, that's 3 squared, so that's 720. And that's x cubed, y squared. Next one here, 2 squared, that's 4 times 10. We'll do the 10 next. That's 40 times 27. 1080. x squared y cubed, and I'm going to start kind of going down below that. Okay, now the next one here, we got 2 times 5, that's 10, 3 to the 4th, that's 81, so that's 810 x y to the 4th, and then we're going to have 1 times 1 and 3 to the 5th. So that's 3 times 3 times 3, 5 times, that's 243 y to the 5th. So that right there, sorry about kind of going below the other one there, that is my answer. That's the expanded form of that right there. Okay, so once you get the first one down, these are kind of tedious, they take a little bit of time. Once you get the first one down, that power of that first term goes down by 1, the power of the second term goes up by 1, but the degree must always be 5 of each one of these. So 4 and 1, that's 5, 3 and 2, that's 5, 2 and 3, that's 5, 4 and 1 again, and 5. Okay? So make sure you're careful when you're multiplying out, and make sure you're careful when you're getting your degree. So the second one, we're actually going to use the binomial expansion theorem. Okay, that's that NC0 x to the n, y to the 0, and then it just goes down by 1, and then we get NCn all the way at the end, x to the 0, y to the n, so they switch places. Okay, we want the 7th term. Alright, so remember, in class, when we're looking for that 7th term, we're starting at 0, so really we're going to use 8C6. Okay, because this is always down by 1 since we're starting at 0. Alright, 8C6. That matches with the power out front. 6 is that minus 1. Okay, then we said that this number right there, the 6, that's going to match my second term's power. So it would be negative 5 to the 6th power. Alright, since our degree has to be an 8 here, our degree has to be an 8 of this, so that means this is going to be m to the 2nd. Okay? So if you put that 8C6 in your calculator, you get 28, and then we have m squared, and then negative 5 to the 6th power. That's going to give you a positive 1,506 or 15,000, excuse me, 625, and we multiply that by the number out front, which is at 28. So we get 437,500 m squared. So yeah, it's kind of a big number, but that's what happens when you have a negative 5 to the 6th there on the back end. Okay, that gets us to that big number. So hopefully this helps a little bit. Alright, you guys should have binomial expansion theorem written in your notes, but the thing to remember here is we're looking for the 7th term, so that number is always that term you're looking for minus 1. So it'd be 7 minus 1 gets me to a 6. So that's how I know the combination out front. Okay, and also the 6 is the power of your second term that's in your binomial. Okay, so negative 5 is your second term. I'm going to take negative 5 to the 6th power. Alright, and since these have to add to give us a degree of 8, we know that that m is just going to be squared. Okay, so work through the homework. Let me know if you have questions. Hopefully this helps. Thanks.